Speaker from our side. You heard about Feature Store a lot today and how Feature Store helps and augments in improvement on the data science workflow. So we have Chetan from H2O team who's kind of going to provide a brief demonstration of the Feature Store product for the audience to have a peek at. Thanks.
Okay. Hi everyone, my name is Chetan. So I work for H2O as an AI architect, and my role is basically to work with customers to ensure they use our products properly, they see success and value of the products. I also do work closely with different teams within H2O in developing new features within our products as well. Okay, so today's topic on Feature Store, I'm sure this morning some of us would have seen the demo and talk from AT&T as well, and from Paul. So what I'll do today is we have very less time, and so I won't be able to do a full-fledged end-to-end demo, but instead we'll basically jump through a few slides, and we'll look at the Jupyter notebook, which we'll use to maybe run a few cells and see how certain operations in Feature Store will work. And third, we'll look at the Feature Store UI and then and basically see how we can get a feel of what Feature Store looks like, right? So let's have a look at all those things. Okay, so yeah, I think I'll skip this slide. So so this slide, I think some of you must be familiar. Let me do a slideshow. Yeah, so as you can imagine, a lot of time just goes in figuring out 60% of the time, right, in collecting data, in cleaning and organizing data, and that's where a lot of organizations spend their time in ensuring they get their data pipelines in place. Even though we might end up installing and configuring our AutoML tools and platform, but they wouldn't be able to see or realize enough benefits and value because it takes a lot of time, especially in large organizations which are regulated, to be able to clean there and get the data in shape. And if you look at the training, building the training sets, 3%, collecting data is 19%, mining data for patterns 9%, refining algorithm 4%. So the whole the whole model build process is actually not that time consuming. So most of the time, is sorry. Yeah. So most of the times, what happens is, yeah, we just spend time trying to get our data in shape. So the next one, yeah, H2O Feature Store. So what it does is basically it's optimize the feature engineering and model. Sorry. Yeah. So the H2O Feature Store, it basically optimizes the feature engineering and model building process. So we do have a whole bunch of capabilities in that. I'll quickly talk about those capabilities. One is we have the concept of what I'll do is I'll just go to the docs and open the Feature Store related information. Yeah, I think it's a lot easier to talk about these things. So we got the concept of, like in most of the feature stores as well, we got a concept of offline feature store. And for offline, right now what we use basically is, as things stand today, is S3 or Azure Blob Storage, right? So now that could change going forward. We might end up adding more and more primary data sources. Now, for online feature store, it's used for, let's say, for anything that's got to do with fast data or real-time kind of use cases. We have online feature store. We use Redis primarily right now as a means to support the capabilities of online feature store. We have Mongo, where we store the metadata. We've got Redis, which hosts online, and we will be moving actually to Postgres of Mongo to store the metadata information. So we do have a lot of connectors when it comes to ingesting the data from different data sources into Feature Store. So we have JDBC connectors. We work very well with Snowflake as well, and I can show you a quick, maybe a code snippet on how the Snowflake integration works. And we integrate very well with Apache Kafka as well. So when it comes to real-time scoring, I can show another snippet there as well. So how we could use a combination of online store and use Kafka, and then maybe score, let's say, model deployed in MLOps and with a REST API endpoint. Now, the other important component is basically the compute portion. So the storage, we just talked about the storage. The compute portion is actually all the transformation that we do. It could be, which is primarily used for your typical last mile data prep kind of work. So everything is done on Spark. So which means that out of the box, we do support certain transformations. For example, let's say things like, if you're familiar with driverless and H2O3, we got mojos. So you could basically download the mojos and score within Feature Store, right? So all your scoring is done within Feature Store, right? So that's an option that works really well. And the other bit is, if you're able to define your transformations as a custom Spark processing pipeline, you will be able to do those transformations. So let's maybe a good time to just go through some code. Okay, so let me clear all the outputs. I won't be able to run every single cell, but what I'll do is let's look at the important bits, right? So let's go to Feature Store projects. So this is how the UI looks today. It's integrated within our cloud platform with the latest version of AI Cloud. And so let's look at maybe this H2O, the one which I just created today. I was playing this morning. So I've ingested two feature sets. One is from Snowflake and one is from S3. So within the project, you have these. You can start listing, seeing feature sets. So the other important aspect is access control, which is essentially project permission. So here, this is a good way for people and teams to collaborate between each other. So if you have a feature set, one of the use cases, one of the important uses of feature store is reusability, right? So if you have a feature set which is useful for, let's say, one of your use cases, you want to share it with a different team member. So the person could actually, in the UI, say, I'll show that later. But so in this case, so Jenna actually has requested saying that she needs access to be able to use this this feature set, right? And I can then either approve or reject, and let's say I just approve. And next time when she logs in, she'll be able to access this feature set and do whatever operations she wants to do. Now, yeah, and again, I can revoke this at any given point in time as well. So let's see what's inside this feature set, right? So this project, so let's look at feature set permissions. That's fine. So my projects, if I go here, go here. So here we say that, look, we got two feature sets, the version. So every time we ingest a feature set, there's a version number attached to it. And you could bump up the version as well. And let's say when you're trying to do some transformations, you automatically create derived feature sets, and that'll have a new version number as well. So if you want to move between versions of feature sets, you could do that too. And here in this case, we've got two columns essentially. And if you look at these columns, you got this is the scoring data. We just have the primary key and the label. So you just have two attributes. And here you could see the important ones, the flags here, special items. So if you see here, so I could mark when I'm creating a feature set, I could mark certain columns as sensitive. And if a user, depending on the permission the user has for that feature set, when they view the feature set, the data will be actually masked. So from a governance standpoint, this capability works really, really well. So yeah, this is the preview. So if you look at right now nothing's masked, so you don't see anything. But if it were to be masked, you would see some garbled figures and data here. Let's go back here. The other aspect, I'm running just 9. Yeah, I think I have time. All right. So the other aspect is, let's look at driverless. So if you create a feature set, we have within driverless, you must have seen this these screens before. We have a lot of connectors from driverless, right? So including but not limited to things like Snowflake, JDBase, and others. So we also have feature store which is integrated in driverless. So if you were to click on this and let's say click on feature store, you could then see a project. So these are projects that I have access to, and let's say transactions feature store, and you can browse to the feature sets here. And there is one which is meant for training. So you could import. I won't run through the whole training process, but it makes it very easy to pick a feature set from feature store into driverless and run an experiment. And once you okay, so I won't run through the training process, but you can run an experiment, and if you were to generate a mojo, you could then, let's go back to the notebook. So if you were to generate can you see the font? Should I increase it? Plus people in the, yeah, okay. So if you, I know, I'm sorry, I'm jumping back and forward, but I'll complete the mojo bit and then we'll go back and talk about transformations. So here, for example, here, so these are transformations that we get out of the box. We just have to do this import. And so this is the mojo which, let's say this is not the same mojo which I'll be scoring, but let's say we got a mojo from an experiment. And all we need to do is do a get a handle for the feature set from the feature store. And we get the schema out, and then we register it as a new feature set. And all we need to do is basically run this ingestion job, right? So once it's done, what happens is you'll see in the feature store, you'll see the results as well generated and stored as a derived feature set. So this is the scoring bit from this again within using the offline feature store, right? I'll talk about the online bit later. Now we'll look at what we didn't talk about is transformations that you could do. So yeah, maybe let's start from here and go through some of these sections in the notebook. So there are 5 levels of permissions. I did talk about briefly earlier. So when I showed how Jen requested for permission, so I could say that person to be granted permission as an owner, editor, sensitive consumer, or viewer. And so when I'm creating a project, right? So I could do this here. So I could, for example, say project, and let's say. Add consumers, and then give the names. It could be a list of names that you might want to add. And so let's say you go to if you're ingesting from Snowflake, all you need is basically a way to connect to Snowflake. You need to have the credentials, and then you just run an ingestion job. Same thing with S3, and same thing with any other data source you might have. So this is an example of the transaction abuse use case. I won't go into the details of the use case specifically, but in this case, imagine this to be a scenario where you have teams working on different models, and you might want to get the model outputs. In this case, let's say we have a model for toxicity, you have a model for emotions, you have a model for sentiments and things like that. So you could basically, and let's say these are feature sets in feature store, right? So you could extract these, you could ingest these into feature store, and once you ingest these, you could then, again, you can share this with the different teams if you want. And let's say you want to do a couple of joins. So typically, that's one of the primary use cases, right? To do your last mile data prep in feature store. So let's say we got, so there are different ways you could actually do a join. But in this case, what I'm showing you is basically an inner join with 2 keys, and we're joining 2 feature sets to get that transformation here. So similarly, in this case, what we're doing is basically getting a handle for all the different feature sets. And so the sequence of steps is you get the feature set, you create a schema, and then you do an operation, right? So we do an ingest, for example. So now we've got, so we've got basically all the gets are here. Register, get, yeah. So the other thing I mentioned earlier was the custom Spark pipelines you could run. So this is an example of a fairly complex series of, a group by operation. So this is, as long as this conforms to the PySpark, way of defining things, what we're using here is SQL transformer. As long as it conforms to that, you will be able to define a custom, Spark pipeline and run that, right? Now, once you do that, again, this comes up. This is stored as another derived feature set. So this is the same. I won't repeat this. We went through the mojo scoring bit. Yeah, the online feature set. So this is a good one. So here, what we're doing is we have the schema. We do a get on the feature set here. We have, in this case, we have deployed a real-time endpoint, a model in MLOps. We have a real-time endpoint, a REST API endpoint defined there. And what we do is, this notebook actually uses Kafka, but the thing is that we basically, the data that needs to be scored is in Redis. So we read the data from Redis, and the consumer reads it from Redis. So we have a topic defined. We push the scoring data into Kafka. And on the other side of Kafka, we basically receive a score and then push it back to online, right? So that's what we are doing here. And then this shows a good example of how to do online. Now, if you were to, let's say, think of a use case, and then let me bring this up. for any use case, I think a lot of these patterns will be common. So let's look at this one, right? So this is something which we've been working on, and so can you see this? Or should I? Oops. This okay? Yeah. So this is a typical kind of workflows that you can see, right? So we can ingest from HDFS, Snowflake, wherever, right? So any data source, we ingest into feature store. So we define the concept of project, which is what we did. You can share projects and feature sets. We showed that. I showed you that. Then in offline store, you can do a bunch of transformations, which is things like group by and join, but you can do a lot more than that. And you can create derived feature sets there, right? Now we did see how we could ingest the feature set into driverless to train. There are two ways to score. One is you could deploy in MLOps as a real-time endpoint and do online scoring, or the other option is we export as a Mojo, and you could score within feature set as a Mojo, right? Now, online and offline, a sync happens. So I don't quite remember how frequently that happens, but so if you were to start scoring and pushing the results into online, it automatically syncs into it materializes offline as well. And if you were to consume the final set of predictions and show it in a, like a Wave app or something, so you could then use the APIs to tap into the offline store, even the online store, and then show the results in the UI. So this is, yeah, I think if you got a few minutes, I'll probably stop here for questions. Yes, it will automatically do that. Yeah, you can force it to materialize, but even if you don't force, it automatically syncs to the offline version. Yeah, so I think if you want that if you want the transformation to kind of in some sense like very versatile, right? So if you want to do something funky as part of transformations, you could do that within your Spark pipeline. Meaning if you're able to define that transformation as part of, as like a Spark pipeline like we saw in that a large group by, right? So that way you should be able to do pretty much whatever you want. But let's look at, it can be, yeah, custom as in, let me show that block of here, right? So this one, so as long as it is a PySpark conformant one, so if you define this as, yeah, if it's a Spark pipeline, if you're using SQL transformers, and this is a query, right? So this query can be like your typical PySpark query, right? It could be anything. So as long as you're able to define it in this manner, then you could. So out of the box transformations, you would have things, let's look at supported derived transformations, driverless AI Mojo, join. So joins are popular. That's a common one that we use quite a bit, and yeah, I guess APIs. Yeah, I think we can look at the docs later, but this will have a lot more information than I've shared with you. The other thing which I forgot to mention is that the ingestion can be scheduled. So you could say, we first do an ingestion for the first time, and then we want to have, let's say, the new data, only the change data to be ingested. So that's already supported right now. So you could set it's a cron-like schedule that you can kind of define, and that ensures that whenever you get new data, it ensures only that the delta, the incremental data is actually ingested back into the same feature set. Yeah, and whatever you see, the UIs, I think what you saw is kind of light, but the next version will have, the aim is to be able to do whatever we can with the APIs in the UI as well. Yeah.
So feature engineering is a very vast subject. Now, as a data scientist, we use different techniques for feature engineering. What my question was exactly was, is there some predefined feature engineering techniques that you guys have provided? Because we know we can customize it through Python and our thinking, like, and every use case might have a different feature engineering or feature engineering set. But are being solving many use cases right now through in the banking. Are there any pre-available feature engineering techniques which can be thrown out, and let's say for a particular use case, these sets of techniques can be used? Because we are talking about feature store, so maybe as a feature of feature store, but again.
Yeah, I think I would like to basically draw a line between the feature engineering that is done within the model build process and what we call as feature engineering while doing in this context, right? So, I mean, this is a place where we would ideally not do the feature engineering, which, for example, driverless does within, or any tool that you pick, right? So, leave that aside. But here, I think the purpose would be to ensure we basically do some, data prep or some transformations. That could mean actually generating new features. For example, let's say you have a date field or timestamp field, right? We might want to do something out of that. So you could still write queries or transformations to do that. That from a definition standpoint would still qualifies as a feature engineering thing. So those you could still do it. But again, those would be limited by what you can do within the framework of Spark. Right. Yep.
Thank you. The separation of building the features, as part of data prep outside H2O, and then obviously the ones which are generated within driverless. Is there any roadmap for cataloging the features generated within driverless AI?
Yeah.
Okay.
Oh yeah, actually, so we didn't talk about that. So we talked about after, let's say, a model is built from the mojos, you could score, but there's also an option of just extracting the features from the mojo, not using it for scoring purpose,
yeah,
but just to get the features out. This is already supported.
And so when you say extract, would that give you the code, whether it's SQL, Python, and so forth, so you can choose what type of code you extract?
Yeah, so in the context of feature store, it's not code, but with feature store APIs and the mojos that we get, so it's like a transformation that you use to get the features, not the code. The code bit is what I guess we're discussing earlier in the morning today, is from driverless you could tune for fine-tuning purpose. You could download that, export as a custom recipe. The intent is again to, we'll give you that piece of code that is used for feature engineering, and you could do whatever you want with it, right? So you could extend that further. But that's outside of feature store.
Final question, plans for integration with CI/CD type of tools?
Well, so it's all, we have Python and Scala support for this, right, from an API standpoint. So I think right now the approach would be to use those APIs to integrate with your existing CI/CD framework.
Okay, thank you.
I've seen this GCP's feature store. So actually they have, the example that they showed us was of a recommendation engine data frame based on movie data set. So actually instead of the features being the columns, they actually made the transformation, right? So you get the viewers or the reviewers for a movie. So that is brought into the feature store, right? Like there are people who watch horror movies.
Yeah.
So that is like an additional ability that
you're
they're
talking about
giving.
the feature recommendation?
No, yeah. So they're building feature recommendation into the feature store.
Correct. Yeah,
so I mean, something like that would be very useful for CBA because if we have a data frame, typically the customer is the row, right? But it would be nice to have a feature which marks a customer, groups of customers as risk averse or,
correct.
Yeah. So if we build a feature store, I mean, would that be easy? I mean, it's not easy to do right now.
I understand. So we do have feature recommendations. We got like an initial version that is there today. So let's say if you were searching for a certain feature, right? So right now it's limited to, I think, based on the, I guess, the schema and the column that you're using. But to your point, I think that is where we want to head towards in terms of doing supporting a full-fledged recommendation, right? So let's say your use case is fraud. Then we should be able to surface and say, do you want to look at these feature sets, right?
Correct.
So yeah, I think that's on the plan. The other thing I forgot to mention is we have the ability to define custom tags as a user for every feature that you create. So right now, I think one of the options could be to, when we're creating a feature set, to add those custom tags, so that it helps in search and discovery process. It makes it a bit more easier while we wait for this thing to be supported out of the box.
So, Chetan, in this case, it might be overlapping also when we are creating the tags, right? Metadata tagging is being done.
Yeah.
How we are making sure that there is no overlap over there?
Yeah, I think if it's good one. If it's a human created tagging thing, there's bound to be there's bound to they'll be bound to seeing overlappings. I think that is something which we'll have to kind of work with to ensure it doesn't happen. But the other thing could be having a combination of like creating a tuple, right? So it could be a combination of tags plus a combination of maybe using the feature recommendation APIs itself. And I think we'll have to try out a few different options.
So, in this case, as of now, if there is overlap, is it giving equal importance to both the features, or it is something that
No, I think the tags is primarily here for only to aid like your question earlier, right? So because we don't have a full-fledged capability of that, but one could use this tags as a means to, if you want to search a feature set for movies or for something, right? So you could do that.
Sure.
That's all. It's more like a stopgap thing for now.
Yeah, thanks.
That's all. All right. I think if there are no more questions, I'll stop and thank you.